In lesson 7.1, writing and solving one-step inequalities, it's how do we write and solve these one-step inequalities is our essential question. So what we're going to work on in here is when adding or subtracting the same number on both sides of an inequality, the inequality symbol stays the same. When multiplying or dividing by the same positive number on both sides of the inequality symbol remains the same. When multiplying or dividing by the same negative number on both sides of an inequality, the inequality symbol reverses. And then to check our solutions of an inequality, you choose a number in the shaded part of the number, you substitute it into the inequality and see if it solves. That's the original inequality. So looking here at the explore activity number 1, we have to complete the table and is the inequality true or false. So we have the inequality of 2 is greater than or equal to negative 3. We're going to add the number 3 to both sides. So then that's going to give us 5, because 2 plus 3 is 5, is greater than or equal to, and negative 3 plus 3 is 0. So is 5 greater than or equal to 0? And the answer would be true. Okay? And then you would go ahead and do the same things for these here. In the next table here, we do kind of the same things, except we're going to do some divisions. So if we take 4 divided by 4, that's going to be 1. And we take 8 divided by 4, that's going to be 2. And we have 1 is less than or 2, and then that would be true. You can do the next one, this one here. I want to show you what happens here. If I take negative 16 divided by negative 4, that's 4. And if I take 12 divided by negative 4, that's negative 3. If I keep the sign, is 4 less than or equal to negative 3? Well, then the answer is no. So it's false. So let's take a look at the work. I did the work over here in this one. Again, negative 16 is less than or equal to 12, so that's a true statement. I'm going to divide by negative 4. So negative 16 divided by negative 4 is 4, because a negative divided by negative is a positive. And then a positive 12 divided by negative 4 is negative 3. This is that special case where we're going to switch the sign when you are dividing or multiplying by a negative. So then this really is going to become 4 is greater than or equal to negative 3. This section right here, this is what I just already talked about at the beginning for addition and subtraction properties of inequality. For addition, you can add the same number to both sides of an inequality and the inequality will remain true. And the same is for subtraction, and that will remain true. Here in example 1, they have a inequality for us to follow. It's a one-step. They show us the steps here. To isolate x, we have to subtract out the negative 5, or subtract out 5. And what we do on one side of the equation, we do on the other side. So now we have x is less than negative 17. They now ask us to graph it on a number line. Notice here they use the open symbol. They start at 17 because that's what we found here, but it's not included because x has to be less than negative 17. So we use the open symbol for that. They come in and they show you a possible solution. They take negative 18 because you can use any number in this shaded region all the way down as far as you want and put it in here to see if that inequality is true then. So negative 18 plus 5 is negative 13. Is negative 13 less than negative 12? Yes, it is. So the inequality is true. They show us another one-step equation here. This time we're going to add positive 3. So we add 3 on this side. So we have 11 is less than or equal to y. They're saying that y, any number greater than 11. So when we graph that out, any number that's greater than 11, so going this way. But also notice here they use a solid dot, and that means that 11 is included in the solution set because we have the equal sign there. We have less than or equal to, and that's why 11 is included. Okay, for multiplication and division, we only have one difference than before, and that's right here. So you can multiply or divide both sides of an inequality by the same positive number, and the inequality will remain true. If you multiply or divide both sides of an inequality by the same negative number, and that's the key, negative number, multiply or divide, you must reverse the inequality symbol for the statement to be true. This is the important concept here. All three of them, addition, subtraction, multiplication, remain the same. You keep the inequality symbol the same. Negative number in multiplication or division, you have to reverse that symbol, the inequality symbol, for the statement to remain true. So looking here at a couple examples, y divided by 3 is greater than or equal to -5. We have to, this is a division, so we're going to multiply out the 3 so that they would cancel. So now y is greater than or equal to 15. We have a solid dot here. That's the 15 is included because it's an equal, greater than or equal. And then any number greater than 15 will satisfy this solution. And then down here, step 3, they show you an example of a number that you can use. So 18 divided by 3 is 6. 6 is greater than or equal to 5. Looking at the next example here, -4x is greater than 52. So this is the -4. So we're going to have to divide out by -4. So what we do on one side of the equation, we have to do on the other side. But since we're multiplying or dividing by a -4, and we're talking about that step here, so we're dividing, we have to change the sign. We have to switch it around, okay, so that the inequality will be true. So 52 divided by -4 is -13. It is not an equal, a greater or less than or equal to. So this has the open dot, okay, so 13, even though that's where we start at, 13 itself is not included in the solution set. And then if you go ahead and you take any number and you put it in here, so they used -15 times a -4, so negative times a negative is a positive, and of course 4 times 15 is 60, so 60 is greater than or equal to 52. Example 3. They have a word problem here. A marine submersible descends more than 40 feet. As it descends from the sea level, the change in elevation is -5 feet per second. So this descends right here is captured already in the negative there. How many seconds does it descend? Does it take it to descend? So they go through and they set this up. Down here lists the important information. The final elevation is it's more than 40 feet below sea level. So since we're below sea level, okay, we're below sea level, we're going to use a negative, because if you drew a picture, here's sea level, that's 0, going up, of course that's up in the air and elevation, and that's going down. So we're down here at -40. And then the rate of descent is -5 feet per second. Descent, of course, means to go down, and that's captured here in the -5. We're going to go ahead and write and solve the inequality. So -5t is less than -40. So we're going to get rid of our -5, we have to divide by -5. So we have to switch this around because we're dividing by negative. And then -40 divided by -5 is 8. So t is greater than or equal to 8. T is greater than 8, so 9 is greater than 8. So -5 times 9, is that less than -40? And it is. You see, we're simply following our 1- and 2-step equations that we've already done. The only things that we've introduced to you that's new is about switching the inequalities for if you're multiplying or dividing by a negative so that the inequality will remain true, and also using graphing the solution set if you have whether the dot is open, whether the dot is included, or whether not included, or whether it is included. Again, this would be for greater than, this would be for greater than, less than. This would be for greater than equal to, less than equal to, and that's what you look for there. Hope this helps you out. Have a good day.